All right, so we're going to talk about patterns and expressions today. So we're going to start here. Part of mathematics is being able to understand patterns and be able to and how to relate with them. So here's our first pattern. So here we have a triangle, a square, a pentagon, and a hexagon. So what is the pattern? One of the things that you have to be able to do is be able to describe it. So the pattern is adding one more side to the diagram. Okay? So adding one side. Okay. And then what would the next figure be? Well, how many sides would it be? So if I had 6, the next figure would be 7. I'll try and draw this. 3, 4, 5, 6, 7. Okay, so a heptagon. Okay, so we have this idea that patterns. Mathematics is built on patterns, and we want to be able to see those patterns and identify it. So we do have some vocabulary that we need to make sure that we understand. So the first thing is a variable. A variable is a symbol, usually a letter, that represents one or more numbers. So in algebra, a lot of times we'll use x and y are pretty common, but we can use n, we can use a lot of different letters and symbols. There are some letters we just do not use though. Okay? So the next thing is a constant. A constant is a quantity that does not change. 5. It is always going to be 5. Okay, so it does not change. Numerical expression is a mathematical phrase that contains numbers and operation symbols. Plus, minus, multiplication, division. 3 plus 5, quantity 8 minus 2 plus 5. These are numerical expressions. And then we have algebraic expressions. So an algebraic expression is a mathematical phrase that contains one or more variables. Okay, 3n plus 5, quantity 8x minus 2 plus 5n. Okay, so these are right out of your book. So go ahead, they're right there that you guys can take them down. The next thing is being able to express a pattern with algebra, because that's what we're really looking at here. And being able to kind of identify what that algebraic expression would be. So here's our pattern. So we have one square, and then we end up coming up with 2 squares, and then 3 squares. And our question would be, how many sides are in the 20th figure? So what I'm going to show you is kind of using that, what they call a process column, to kind of identify a pattern here. Okay, so here we have figure 1, so this is figure 1, figure 2, figure 3. And we notice here the amount of sides that we have here is 4, then we have 8, and then we have 12. And so my figure here is figure 1, so my figure number here. My process column is kind of what operations am I doing to get to my number of sides. So I end up with 4 sides, so I have 1 times 4. And you notice here, every time you add another square, you're adding 4 more sides. So my process column for my second one is 2 times 4, which is 8. 3 is 3 times 4, which is 12. So my nth processing column would be n times 4, or 4n. So this is my algebraic expression. It's going to allow me to find any of my figures. So now it says, what is my 20th? So I would go 4 times 20, or 80. So the 20th figure will have 80 sides. Now, one of the things that we want to make sure that we kind of be able to understand is these patterns can be put into graphs also. So if I had a graph here, so we'll make this 1, 2, 3, 4, 5. We're going to make the side over here 10, 20, 30, 40. If I were to put dots along here, you should still see a pattern built out of this graph and be able to identify, where do you think 4 would match up with? Well, this pattern looks like it's kind of going diagonally, where each one is matching up with the corresponding one if I drew right. And so you would probably think 40 would match up with 4. okay? So we want to be able to look at graphs and interpret information from graphs. So that's kind of analyzing patterns and expressions.